So there's where we were on J. We were going through deciding whether the information given was enough to define one unique triangle. And it was really all about those three-letter combos, wasn't it? Side, angle, side, 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 side. It's usually those two, right? One of those kind of things. Remember that? I'll just run over real quick again. So we looked at A here, and it said, what if you have a triangle of sides 18, 27, and 36? So if you have a triangle of sides 18, 27, and 36, there's only one triangle you can make like that. You know what I mean? You might think, well, no. Can't you do 18, 27, 36, and then make a triangle that looks totally different that's 18, 27, 36? No, you can't. If you have two triangles that have the same three sides, they have to end up being identical. They will be identical. You can't actually make two different triangles out of those same three sides. You'd have to use different sides. How do we know that? That was the side, side, side theorem. Remember when we first proved that? Way back here? We didn't prove it, but we saw that. Right here. Side, side, side. That's what that meant. It says if three sides of one triangle are the same as three sides of another, those triangles are identical. They have to be. So, and that's what we're talking about on this question. Is I'll just pick it up right here. If you have 18, 27, and if you have two triangles that have the same three sides, those triangles are fully identical. They're the same triangle, really. There's only one triangle of that type, in other words. So that's what it was all about. They wanted us to check the boxes that just had one unique triangle. So, yeah, for sure, this one, side, side, side. The second one was the same thing, 9, 12, 15, side, side, side. And then part C, remember the deal with part C? They gave us three sides again, so why isn't it just side, side, side? But remember how part C, the issue was, it's an impossible situation. It's not one unique triangle because it's not even a triangle. It's impossible. Remember, you can't have two sides that don't add up to be more than the third side because that wouldn't really work in the real world. Let me show you what I mean. So the 1, 6, 8, that's actually impossible. So if you had 1, 6, and 8, they wouldn't even connect up to be, it'd look something like that. It wouldn't even reach to make the other side, right? Because 1 and 6 would have to be longer than 8, you see, to reach and connect the other side. They're not going to even reach. If you stretched them all, if you took this 1 and the 6 here, and you stretched them straight, they'd only go 7. They're not going to reach the end of the 8, are they? So there isn't even a triangle that exists like that. That's make-believe. So that's why we didn't check box C. That's not one unique triangle. That's not a triangle at all. And then went on to D, and they said equilateral. Well, yeah, equilateral, that means, three sides that are all the same. So that's side, side, side again. So yeah, that's only one unique triangle with sides of 6. And then triangle with sides 18, 21, and what did they say? 18, 21, and an included angle of 75. That was side, angle, side, right? If you have a triangle that has 18, 21, and an angle between them, an included angle of 75. Yeah, there's only one way to do that. Can you feel that? What I mean is, what if somebody said, okay, here we go. I'm going to give you a triangle. One side has to be 18. The other side has to be a little longer, 21. And you have to have a fixed angle of 75 between them. But do whatever you want with the other side and the other angles. Well, you don't really have any freedom, do you? There's only one way to finish that triangle. You have to connect those two dots, huh? Is that good? So did you see how that determines only one triangle is really possible with that information? That's enough to hardwire it, so to speak, to kind of determine it, fix it, decide it, right? If you have, this side of 18 is set, and that side of 21 is set, and then they also set the angle rigidly between it so we can't make it bigger or smaller. And then they say, do whatever you want with the other side. Well, we don't really have any choices with the other side. We're set. We have to connect the other two. There's only one way the other side could be there. There's only one way that triangle could finish. Right? So do you feel the truth? I'm just trying to help you feel the truth of side, angle, side. That's side, angle, side. That's another three-letter combo. We check the box. There's only one way to have a triangle with those two sides and an angle in between. On to just the same stuff. So we just did this one. So A, B, D, E. Coming on down to F now. So F, a triangle with sides 18, 21, and a non-included angle of 40. Non-included angle of 40. So 18, 21, and then some other angle. So it's not a 40 there, huh? It's not that. It's a non-included. So maybe the 40 is like over here on this side, or maybe at the top, up at the top. It doesn't matter. It's just not between them. Does that make sense what they're describing? So what if you have an 21, 18, and then a 40 that's not between them? Does that define only one unique triangle, or is there more than one way to do that? What do you think? Are there options? Could you make a different triangle that has 21, 18 and a non-included 40, or is there only one way? It's all about the three-letter combo. What three-letter combo is that? Angle, side, 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 angle, huh? So is that one of the ones that does it for us? That's the bad word. Backwards, right? SSA or ASS, right? That's right. I tried to help you remember it, right? That's the no-go. That one in AAA are not enough information. There's actually another way. In fact, you could even see it right here, right? What's the other way? You could put the 40 at the top, and that's going to be a different looking triangle. And they both have the same angle and two sides where the angle's not between, and yet they're different triangles, huh? They're going to turn out to be very different triangles. So that's not enough information to determine one unique triangle. The bad word, ASS, forward or backward. I was asked in the last class, it's a good question. Somebody was asking, which way. So you can do it either. You can go SSA this way, or ASS that way, or whatever. Either way, it doesn't matter which direction you go. ASS, SSA, it's all the same thing, and it's not enough information. How about H here? A triangle with sides 8, 8, and a non-included of 40. Let's try that one. 8, 8, and a non-included. So where do I put the 40? Where can I not put the 40? How about that? Yeah, I can't put it in the top between them. So you could put it over here, left side, right side, whatever. Just not in the top, huh? So what do you think about that one? What three-letter combo is that one? Two 8s and a 40 not between them. What three-letter combo is that? Yeah, there it is again, huh? Right? Isn't that one angle, side, side, right? Because the angle's it's not SA. Do you guys see how we know the difference between that and SAS? Like over here, we had SAS, right? You see that picture? Because we had the angle between them. So if you have the angle between them, back on E there, then yeah, that fixes the deal, doesn't it? If you have the angle between them. That pins it down to just one type of triangle. But over here, with the two sides and the angle not between them, there's options. It's the bad word. It's not enough to determine one unique triangle. It doesn't always make one unique triangle. Right? We good there? But this one's actually got an extra wrinkle to it. Yes, normally, ASS, the bad word, is not enough information. Normally. But this is a little bit of a different case here. Why? Because they made these two sides the same. They made the two sides the same. Okay, so what? They made the two sides the same. What does that mean about the angles opposite now? Are you familiar with, let's talk about triangles, sides, and angles and how they work for a second. Let me go to a fresh room here. There we go. Okay, if you have a triangle and you open a big, this is a big angle here, notice that it makes the side across from it very big, right? Because angles affect the sides opposite them, don't they? Whereas if you take the same situation and you make the angle very small, right? If you make a small angle, it makes the side across from it small, doesn't it? So angles affect the side opposite them. That's who they're connected to. There's this real direct connection, isn't there, in a triangle, between angles and the side opposite them. Bigger angle, bigger side opposite. Smaller angle, smaller side opposite. Okay, so what? Well, that means then, if you have, let me do a better job. If you have something like this, and, well, here, I didn't like that. Let me go one more over. There. And you have, this angle, say, is 40. That's a funny 40. If those two angles are the same, what does that mean about that side and that side? Same, right? Two equal angles are going to produce two sides across from them that are the same. Okay, with that in mind, let's get back to this situation. So this one, in general, yeah, it's ASS. You know, if this was something like a 7 over here, then we would just right away say, oh, no way, that's the bad word, ASS. An angle and two sides with the angle not between them, no way, that's not enough. But in this case, they really gave us more than just the ASS. They specifically gave us two sides that are equal. So what does that mean? That's got to be 40, and that's got to be 40, doesn't it? Because those two sides are equal, that forces the angles across from them to be equal. That's what type of triangle is that? What's it called when the two sides are equal? Isosceles, yeah. That's an isosceles triangle. So that's not just any triangle. See, they're being a little tricky here. They're giving us an isosceles. Well, yeah, if you give me an isosceles, that's a little different story. Because now the two sides are equal, thus the two angles across from them have to be equal. Okay, and then if we know the two angles on the bottom, whenever you know two angles, you always know the third in a triangle, huh? Because there's 180 total. So what's the top angle got to be? Got to be 100, right? To make 180 total. Okay, yeah, so you're probably with me going, yeah, I get all that in this term, but it's still the bad word, though, right? It's still the ASS. Well, now there's other three-letter options. Now that we have all those angles, what other three-letter option, what good word three-letter option could we use? Yeah, angle, side, or side, angle. We could go side, angle, side, or angle, side. There's all kinds of good options now that we know all the angles. So this is enough information in this case. See how they're being a little tricky there? So now it's side, side. It's angle, side. Yeah, it's also angle, side. Those are all some of the good combos. So yes, check that box. That actually is enough information because there was two equal sides. It was an isosceles triangle. All right, let's wrap up question 5 here. H, last one. Right triangle, legs 5 and 10. Do you guys know what the legs are in a right triangle? We haven't. Yeah, it's the two sides that hit the right angle. We call those the legs. So like this is 10, this is 5. Yeah, these are the legs. Yeah, what's the other side called that's not touching the right? It's across from the right angle. This is the hypotenuse. Yeah. So in a right triangle, the two sides hitting the right angle are called the legs. The other side across from the right angle is hypotenuse. It's always the biggest, clearly. Right, anyway. So right triangle, 5 and 10. Is that enough? Is that one of the three-letter combos that's good? Yeah, side, angle between them, side. Side, angle, side, check that box. That defines a unique triangle. There's only one way to finish that thing up. You do a 5 and a 10 and you make a 90, right? If somebody said, hey, okay, I want you to do a 5 here and a 10 there, and I want you to put a 90-degree angle between them, and then finish the triangle any way you want. Well, there's only one way to finish the triangle, huh? There's no options. It defines one unique triangle, doesn't it? By side, angle, side. Yeah. Oh, just one way of doing it. Yeah, no, that's a great question. That doesn't sound dumb at all. Yeah, so if I was saying, well, there's another way. If I say, no, you can do a 5 and a 10, and then you can make it look different. No, you can't. What else could I do how else could I start with a 5 and a 10 and a 90-degree angle between them and finish the triangle and have it come out looking different than the other triangle? I really couldn't, could I? So unique means There's only one way to do it. There's not more than one way to do it. There's not two different looking triangles that both have a 5, a 10, and a 90 between them. There's only one type of triangle that does that. So unique. Only one way to do it. Is that good? Is that good on that? All right. On to number 6. Is it possible to construct a triangle with a right triangle with all sides congruent? Is it possible to construct a right triangle with all sides congruent?
No, not possible.
How do we know that's not possible?
Because one side has to be longer, the hypotenuse has to be longer.
Yeah, exactly. What does it mean if all sides are congruent? All sides are equal. Yeah, what kind of triangle is it when all sides are equal? Yeah, equilateral, right? Like maybe this is 10, 10, and 10 or whatever. Right, yeah. And what do we know about an equilateral triangle? If all the sides are equal, then all the angles are equal too. And so what are all the angles? 60, right? Because 180 total. Yeah, 60, 60, 60. 60, 60, 60. In other words, not right. Not 90 degrees, huh? So if you have all sides the same, all the angles must be the same, they all must be 60. You don't have a right triangle. So here it is. B. It is not possible because a triangle with all sides congruent also has all angles congruent, and they measure 60. Good. All right. Number 7. Name 2 congruent triangles in the figure to the right and tell why they are congruent. So, is this triangle identical to that triangle? So, yeah, it is, huh? And what's the reason? Why are those 2 triangles identical? Yeah, they have the same 3 sides. See the marks? Right? Single mark, that means those 2 are equal length. And double mark with double mark, those 2 are equal length. And then, of course, the one in the middle is same as itself. And yeah, so by side, side, side. And then how do you say the triangle on the left? Is it ABD or ABC? ABD is the one on the left. And then how do you say the one on the right? ADC or CBD? CBD. So that's triangle on the left is identical triangle on the right by side, side, side. Those have to be the same. They have to be identical, meaning all their angles, all their sides have to be equal by side, side, side. All right, so we're just beating this triple letter combo again and again, right? Deeply into our understanding, hopefully. All right, here's a pretty tricky question. So they give us the x minus 16. So that one angle is x minus 16. And the other angle is x over 2. And they want us to find the angle C up at the top. That's not easy. Can I give you a second to see this right here? This mark and that mark are super important because if 2 sides are equal, then, like we were saying, angles across from them have to be equal, right? Isosceles triangle, meaning that angle and that angle have to be equal because the 2 sides are equal. It's an isosceles triangle. So that means x minus 16 has to equal x over 2, doesn't it? Okay, so we can use that to solve for x. So how do we do? How's your algebra? Remember your algebra skills there? What do you do when you got fractions? It's kind of a pain. Pretty much want to get rid of them right away is the answer, huh? Can we get rid of that denominator 2 thing? What are we going to do? Yeah, multiply by 2. And you got to do both sides, right? With an equation, if they're equal, you treat them the same, they'll be equal afterwards. So multiply by 2 there, and 2 here. So all the way through, 2, 2, 2. Equal treatment for everybody, right? Then they'll still be equal when we're done. I like to show the wall of separation there. So what does that give us in 2 times x, 2x, 2 times 16, 32. And what happens on the, what is x over 2 times 2? Yeah, because this is really 2 over 1, isn't it? Any whole number is really over 1, right? 2 divided by 1 is the same as 2, huh? And that way you can clearly see it cancels, and it's just x. Remember that from your algebra days? Now, how do we finish solving for x? We got x on both sides. We got 2x on one side and regular x on the other. What do we do? Yeah, get rid of one of them, huh? Well, you don't want x on both sides. You just get rid of one of them, exactly. So I'm going to go like minus 2x from both sides. And that'll cancel this one out. And the other side, what is 1x minus 2x? Negative 1x, huh? 1x take away 2 is negative 1x. And now we have one more step. How do we finish getting x alone there? Yeah, divide by the negative 1. Right? We don't divide by the we don't put the x here because we don't want the x to cancel. We just want the negative 1 to cancel, huh? And we want to leave the x. So that would give us x is positive 32 because, you know, the two negatives make positive. And anything divided by 1, that doesn't change the number. So we got it. X is positive 32. Well, we got x. We still haven't answered the final. We're almost there, though. In the end, they want c. So we've got x. What can we now do with this x? Can we find this angle here? It's x over 2, and now the mystery of x is over. We know x is 32. So we can put in 32 divided by 2, 16 degrees. That angle must be 16 degrees. See how we figured that out? This angle must be 16 degrees. And the other angle, yeah, you can just say it's got to be 16 else because remember they're equal. You could plug into the formula 32 minus 16, you get 16 anyway. Yeah, they both got to both be 16, don't they? Because remember those angles are equal because the sides across from them are equal. It's isosceles triangle. So now I've got 16 and 16. When you got two sides, you can two angles. I mean, you can always get the third angle, huh? Just subtract from 180. So it's just 180. So C will be 180 minus 16 minus 16. What is that? 32. 148? 140. C must be 148 degrees. And we got it. So that was a little tricky. Questions on that one? I can clarify anything? How about number 9? They want me to find angle X and angle Y in that setup. Can I? All right. Anybody notice anything about what kind of triangle that is? It's got to be equilateral because all the three sides are the same. That's what those single marks mean, right? Those three sides, I don't know what the sides are, but they're all the same. Right? They're all marked with a single mark. So those three sides are all the same, so that's an equilateral triangle. And what did we just talk about? If three sides are the same, the three angles have to be the same. And what are the three angles in an equilateral triangle? 60. Yeah, because they all got to be 60, 60, 60 to make 180. So we got X already. 60. No calculation needed, huh? X has got to be 60 degrees. It's in an equilateral triangle. Okay, so that's the quick one. And now, if X is 60, where can we go from this? So this is 60, this is 60, and this is 60. Where do we go from there? We've got to get all the way over to Y somehow. Kenny?
When you have that 60 degrees right there next to point B,
Yeah.
That angle plus the angle on the other side of the line has to equal 180.
Good, right?
Straight line.
Everybody, yeah, because straight line, huh? Because this is a straight line. Remember, one side of a straight line always makes 180, right? Because halfway around, right? If you make a U-turn in your car, you're going one way. You turn around and go the opposite way, right? My kids always kid me when I do that. I do a lot of U-turns. Again, I'm not very good with directions. They always kid me, right? That's a 180, right? Go one direction, go the other way, 180. So, so one side of a straight line always makes 180. So that angle, so 180 minus 60, that's got to be 120 right there, doesn't it? Very good. So that's 120. Excellent. Now what?
You subtract 180.
Oh, 180.
That's 120 from.
Gotcha. 180 minus 120. That leaves 60. But both these angles together must somehow make the 60, right?
So now you know that since an isosceles, both of those angles are the same, so you divide 60 by 2.
Exactly. Did everybody see this mark and this mark? So those two sides are the same, so that triangle on the right is an isosceles triangle, meaning the angles opposite are equal, aren't they? Yep, good observation. So that means that angle and that angle must be equal to each other. So that 60 must be broken up equally, 30 and 30. So Y must be 30, right? Must be 30 and 30. instead of like 40-20 or something, right? They got to make the 60 equally because they're equal. They're an isosceles triangle. Very good. Did you track with all that? Good little exercise in equilateral, isosceles, angles, straight lines, all that kind of stuff. They're just helping us think more and more about all these shapes. Any other questions, comments on that one? Number 10. All right, determine whether the conditions QR is congruent to NO, PQ is congruent to MN, and R is congruent to O are sufficient to prove the triangle PQR is congruent to triangle MNO, and justify your answer. What do you think?
Sounds like a lot of letters.
Yeah, exactly. I'm joking when I say, what do you think? Who knows? You have to draw that, huh? There is no way to just, unless you're some kind of a genius person, to just read that and know what they're even talking about. We need to draw it and see what it is they're talking about, huh? So let's draw it out. So come in here. So QR, so they're talking about two different triangles, first off. And for the first one, they say QR, so I'm just going to go Q and R. That must be a couple of points on a triangle. And the other triangle has NO. So NO. So I'm just looking at QR, NO. You can make them the left side or the right side, make them the bottom, whatever. And these sides are equal, aren't they? They're saying. That's what that first statement is. Those sides are equal. They're congruent. The equals with a little squiggle above it means they're identical. They're equal. All right. Next comes PQ. So I must need a P up here. For PQ is the same as MN. You've got to put an M here like that. So PQ is the same as MN. Finally, angle R is equal to angle O. So angle R is equal to angle O. Now we're in a position to decide if that's a good or bad three-letter combo. What do you think? Is that a good one or a bad one? What's the three-letter combo there?
Angle, side. Or side, angle.
Yeah, so we have a side, and an angle, huh? A side, angle. So side, angle, or if you do it the other way, angle, side, that's the bad word. So no, that's not enough information. Because it's the bad word. It's right. Pretty much any other three-letter combo works, except for the bad word and AAA. AAA and the bad word don't work. So then it says, give a reason for your answer. Well, they don't have the bad word down here because that's not a good reason, so we just say none. There is no good reason. Does that make sense? That's why we said they're not identical, because there is no good three-letter combo. There's only a bad one. There's not side, or side, angle, side, or HL is hypotenuse leg. We didn't get into that, but it's not there either. Good there? On with number 11. These would be pretty easy. Number 11, part A. Construct any right triangle ABC. So, which of these three is a right triangle? Yeah, I mean, you would like a lot of those on the test, huh? All right. All right, so here it is again. There's that one. Okay, part B. Construct the circle that circumscribes. I'm assuming that's a new word for you. Circumscribes. So, to circumscribe means to go around, to draw around. I don't know if you ever heard of the saying, like, try to circumvent that problem. It means, like, go around it. So circumscribe, so they're saying put a circle around the triangle. So which of these has a circle around a triangle? Well, that one. Yeah, E also. All of those have a circle around a triangle, right? Circle circumscribing a triangle. But remember how they're referring to part A? They're saying, no, we want you to go around the one from part A. See that right here? So that's this one, isn't it? They specifically want you to go around the answer from part A. So the answer is A again, part A again. Is that good? And finally, there's a trick question about the radius. It says, find the radius of the circle in terms of the hypotenuse. So we're talking about this figure. This is our answer. We don't care about any of the other figures. Just going up to our answer we just got. Now, let me draw a circle real quick. What's the radius of a circle? What do we mean by that? We haven't got too much into circles yet. We will later. What's the radius of a circle? Half the diameter. Yeah, it's from the middle to the edge. That's the radius. It's halfway across, Tom. Right? Yeah, and half the diameter. That's right. Okay, so now let's go down and look at our answer from the last part. And let's find the radius of that circle. Because that's what they're talking about, the radius. So if you're going to find the radius, well, you need to start with the center, huh? So where's the center of that circle? Well, it looks like it's about right there, doesn't it? Right there. And the radius would be from right there to the edge. So what if I go to the edge like that? That would be the radius, right? That's from the middle of that circle to the edge. And what part of that hypotenuse does it look like it is? It's a half the hypotenuse, isn't it? See that? See what they're saying there? The radius is half the hypotenuse. The radius is half the hypotenuse. When you put a circle around a right triangle, when you circumscribe a circle around a right triangle, the radius will be half the hypotenuse. So they're just hinting on a whole sea. That's the tip of the iceberg, but we're not going under the water. There's a whole, we just don't have time for it, but there's a whole bunch of interesting properties about when you put circles around different kinds of triangles and special things. That's just one of the many. It turns out the hypotenuse will always be, and that radius will be half the hypotenuse. But we don't got time for all that. We got lots of other things we're going to talk about this semester. So a triangle, last one in this section, a triangle has two sides of 10 and 14. What can you say about the third side? What they're getting at here is this is like what we talked about when you have two sides and what the third side being a straight line between 2 points. Let me show you. Basically, you take the 10 and the 14 and you add them to get 24, and you subtract them, take the bigger minus the smaller to get 4. And that's your answer. In other words, the third side must be less than 24 and greater than 4. Let me show it to you physically. I think that'll make sense. So if you have 10 and 14, say this is 14, and say this is 10. If the other side is smaller, see, it has to be greater than 4. If it's smaller than 4, if it was something like 3, if it was only 3, do you see how it wouldn't even be able to reach to make a triangle? Because that's only 13, right? If you straighten that out, it's not even going to reach the end of the 14. See how it can't make a triangle if it's smaller than 4? But if this thing, instead of 3, was longer and was something like, 5 or 6, then you'd have some options for how to connect it up and make a triangle. You see how that other side must be longer than 4 to even make a triangle? And the same thing goes with the 24. I won't bother to draw it, but it's maybe I could real quick. So if you have 10 and 14 again, so if this side's long, if this side's like 25, see, we said it must be less than 24. If it's like 25, then the 14 and the 10 can't reach the end. If this is 14 and this is 10, then you see how they couldn't even reach the end of the 25? 25 would be too big, wouldn't it? It's got to be less than 24. It'd have to be something like 23. We'd have to cut it back to like 23, and then they could connect up to make a triangle. So it's the same thing. You can find the options for the third side by just adding and subtracting the two sides you have. Those are going to be the limits for what the third side can be. Questions on that?